Thank you, Mr. Chairman. Thank you very much for your very nice introduction. Ladies and gentlemen, a very warm welcome from my side. I will not say much about myself. The presentation has already been done. If you're interested in our work, I brought some flyers which are lying around so you can have a look into it. So, talking about the main risks in underground spaces and the lessons learned from the past should begin with some perspective in tunneling. So the percentage of urban population increased during all the times from about 30% in 1950 up to 55% in 2015, and it even will increase furthermore. Up to about 70% is estimated in 2050. Of course, the developing countries, they will start at a little lower value in the early days, but the industrial countries, which had already a very high percentage of urban population, will still increase. So, if we also keep in mind that the population will increase, that the worldwide population will increase by more than 60 million inhabitants per year, and that already in 2015, 10% of the urban population have lived in so-called megacities, that are cities with more than 15 million inhabitants, which are 26 at that time, of which 18 are in Asia. So just to have a sufficient transport in these big cities, underground facilities are needed for public transport, for traffic, for utilities, and also for parking. General, the tendency for underground engineering is that we are building bigger and deeper underground facilities with more critical boundary conditions, both from a technical point of view, but also regarding safety requirements. So the traffic is increasing in terms of person and freight density. There are new fields of application, and unfortunately, there's also an emerging threat by terrorism. So, what has been done in the latest past? For example, very big tunnels have been built in Madrid, for example, the M30, which is already under operation since some years. In Paris, this A86 motorway was built, a very special configuration, this duplex tunnel, which are only for passenger cars, a length of about 10 kilometers. Or on another hand, for public transport, the metro in Barcelona, the line 1, which is a very deep line, which has very deep shafts, and all the passengers have to go down to this very deep level by using these shafts with elevators. Especially the northern countries in Finland, they are very much working in underground spaces, especially Helsinki, for example, has a master plan for innovative policy to transfer the so-called unwanted structures below ground to gain space and quality of life in the city above ground. Some examples for here, given the underground parking, which is below the road surface, below some stores. So the parking is put below ground, but also some tunnels for utilities and also for industry. Some wastewater treatment plants have been put underground in Helsinki. But not only these unwanted facilities, but also they have some underground sports hall in Helsinki underground. However, in winter it becomes very cold in Helsinki, so it might be also some, a little bit more convenient temperature there. So let us have now a look back on tunnel safety, what have been some severe accidents during tunnels, during tunnel operation. So before 1999, tunnel safety, especially tunnel road safety, has not been such a serious problem, especially in the public opinion, because we had rather less accidents, especially much less accidents than in the open, and we did not have too much fires. About 50 fatalities, 50 persons who have been died in a tunnel fire about 50 in about 50 years worldwide. So that it's in average one person, one fatality per year. So yeah, the public opinion was not too bad for tunnel safety. However, there were very few serious fires with up to 9 fatalities, and also one fire lasted about 4 days in Japan. There has been, before 1999, some research, some recommendations, and also some regulations, and also which resulted also in a very few international standards, or which are used in international ways. So rail tunnel safety is much less than road tunnel safety, because there were only a very limited number of tunnel-specific requirements in national regulations. The safety in rail systems is generally quite high, because you have an experienced driver. The trains are running on a rail system, so they are rail bound, and it's not so easy to have collision with other rail systems or with other rail cars. So due to the regulations in the whole system, tunnels were not said to be especially dangerous parts, and therefore there have only been some specification by the network owners. So metro tunnel safety before 1999 was also deemed to be a very safe thing. There are even less requirements for tunnel safety in international regulations. Mainly the stations have been observed, but they were treated like buildings. And especially in a metro system, there's a very low probability of a stop of the train outside a station, because you have this emergency brake overrun. And yeah, even then, the stations are generally used for evacuation. So the safety concepts were very specific for each network, and also very much depending on the standards of the rolling stock. So in 1999 or 2000, the times were a little bit changing, because there have been some catastrophic road tunnel fires in Europe, especially in the Alps. And I put some slides down what happened. So the first very severe tunnel fire has been in the Mont Blanc tunnel between France and Italy. In March 1999, there was a severe fire which resulted in 39 fatalities. So keep in mind, before there were only 50 fatalities in about 50 years, and now one event with about 39 fatalities. So only about 2 months later, there was a second fire in the Tauern tunnel in Austria. And again, in this fire, there were about 12 fatalities. So that means within 2 months, about 2 months, there have been more than 50 fatalities. So the same amount of fatalities which have been observed in 50 years before. However, that was not the last fire in this time frame. So fire in 2001 in the Gotthard Road tunnel. resulted in 11 fatalities. So let's have a look, a little closer look at these fires, especially what has been learned from these fires, the road tunnel fires in Mont Blanc, Tauern, and Gotthard Tunnel. These three tunnels are very similar. So you see here the country in which they are located, Mont Blanc in France, Italy, and Tauern in Austria, and St. Gotthard in Switzerland. So the length ranges from about 6.4 kilometers to 16.9 kilometers. Very important, all of these tunnels are bidirectional tunnels. That means you have oncoming traffic in one tube. So the vehicles density ranges from about 3,000 vehicles per day to about 19,000 vehicles per day in the St. Gotthard Tunnel. And the heavy goods vehicles per day are ranging from 1,300 to 3,800 in the Gotthard Tunnel, like it can be seen here. So the ventilation in all these three tunnels have been a semi-transversal ventilation. The opening was starting from 1965, Mont Blanc, over 1975 and 1980 with the Gotthard Tunnel. So a little closer look into these fires. The fire at the Mont Blanc Tunnel, theoretically, it was a subsidiary, or the operation of the tunnel, the operation was laid into a subsidiary of the French and Italian companies. In fact, there have been two operators that did not cooperate very much among each other, and they have also two independent control centers, one on the French side and one on the Italian side. So the safety in operation, there should have been common procedures since 1985, but only on the French portal there have been private firemen, and the worst thing is that they only had one exercise within 34 years. So, as I said already before, in total there have been 39 fatalities. 27 users died in their vehicle because they did not flee from the fire or did not flee from the vehicle in the tunnel. 7 users and 1 fireman died. 2 users died in another vehicle, and 1 user and 1 staff member died in a shelter. So the main problem in that fire was the smoke. So the lethal atmosphere, which killed especially the users which stayed in their cars. The fire duration was about 53 hours, so it took a very long time to extinguish the fire. And to refurbish the tunnel took in total 3 years, so the opening could only start after these a very long time. So the Tauern Tunnel fire in May 1999, they had 8 people killed in an accident. 1 heavy goods vehicle driver went back to the tunnel and died, and another 2 people stayed in their car and were killed there. And 1 person was killed which tried to flee from the fire, however, did not use such a shelter and died within the tunnel. So the problem was that the fire started very immediately. Although the alert was fast, the firefighters needed a lot of time to arrive on the spot. So another fact was that the smoke control was effective in the very early stages. However, there has been some explosion and smoke destratification in the later stages. So the smoke control, the ventilation was also the main thing what has to be rethinked. So the fire duration in the Tauern tunnel was only, in quotes, 15 hours, 16 heavy goods vehicles burned completely, and 24 passenger cars. The duration to reopen the tunnel was only 3 months compared in relation to the 3 years of the Mont Blanc tunnel. So the Gotthard tunnel fire in October 2001. In the Gotthard, they had also 2 control centers, which each was responsible in turn, so they changed the responsibility every 2 weeks. They had a rescue team at each portal, which consisted of each 4 people plus vehicles. And they had detailed instruction how to act in such a case. And of course, they did also annual exercises. So the fire in the St. Gotthard tunnel started very quickly. The firefighters arrived very fast from the south, but could not control the fire. And the airflow pushes the smoke to the north, so that the firemen from the north had no real chance to attack. Before that, the users could reach emergency exits, especially the drivers of the crushed and burning heavy goods vehicles could flee. Passenger cars, or the drivers of the passenger cars, they tried to make U-turns to flee, but due to the limited space inside the tunnel then was blocked. And also people could escape through the emergency exit. However, especially the people which stayed in their car or went back to the tunnel, they died, so that they have been in total 11 fatalities. So also the lethal smoke or the lethal atmosphere were responsible for a lot of fatalities. So the duration to reopen the tunnel took then about 2 months. So what has been learned from these fatal fires? So the origin of the fire was in Mont Blanc self-ignition, in the Tauern tunnel an end-of-queue accident, and in the Gotthard tunnel a front-to-front accident. The size of the fire was up to 100 or 150 megawatts in the Mont Blanc tunnel. The mean value was set to be about 30 megawatts. In the Tauern and the Gotthard tunnel, it was not done so exactly, so it was much more than 30 megawatts. So the hours which the fire took are given here again. It's extinguishing by users. In Mont Blanc tunnel, the users themselves did not try to extinguish the fire. It's not known for the Tauern and the Gotthard tunnel. Extinguishing the fire by firefighters. In the Mont Blanc tunnel, they did not reach the fireplace. In the Tauern tunnel, they arrived too late, and in the Gotthard tunnel, they did not succeed to extinguish the fire. Evacuation by car, overtaking some vehicles was successful in the Mont Blanc tunnel, not possible in Tauern, and at the Gotthard tunnel, due to the blocked tunnel, only partly possible. So the U-turns you can see here on the French side in the Mont Blanc tunnel, they blocked the tunnel. On the Italian side, it was successful. In Tauern tunnel, maybe it was not. It was impossible to turn, and in Gotthard tunnel, some were successful, some not, and they were responsible for a blocking of the tunnel. So the perception of the risk, which is evident during such a fire, it is not really or not assessed to the real risk by the users, because 25 persons died in their car at the Mont Blanc tunnel, in the Tauern tunnel too, and in the Gotthard tunnel several. So even going back to the tunnel is a very bad idea, because the lethal atmosphere, they will cause that the persons will die. So the right behavior of the users would be very important, but also the right behavior of the operators. On the Mont Blanc tunnel, the Italian side did not switch on the smoke extraction, and on the French side they made other mistakes. On both sides there has not been any exercise, a lack of communication, and the two control centers operated more or less separately from each other. So in Tauern and in Gotthard tunnel, they said all was according to plan, but so rough, no independent investigation probably has been done. So this was more or less about the road tunnels. We were, however, for this seminar asked to a little bit focus more on the rail tunnel fires, but for after these fires, there has been a lot of initiatives on a national level in these countries, on a European level, but also on international levels. And all these initiatives were aiming at some new research, and especially some new guidelines and legislations that these severe fires will not happen again. So, for example, here is some overview of research projects which were initiated by the European Union after these fires, which where a lot of information was gained to make the safety better in tunnels. So, although this started in about 2000, 2001, after these severe fires, some other tunnel fires occurred. So I just want to give some further examples. Some very catastrophic fire accident occurred at the Capun funicular in November 2000. There have been 155 fatalities, so that is some rail-bound funicular in Austria. In 2006, there was a fire in the Via Mala tunnel in Switzerland, also a road tunnel, with about 9 fatalities. You can see here a bus which was destroyed. In 2010, in July, in Wuxi in China, there has been a severe fire within a tunnel with about 24 fatalities. And even somewhat later, in Norway, in the Oslofjord tunnel, there has been a truck getting on fire who carried paper goods, and 9 persons were injured. However, no person was killed during these fires. And not so long ago, in 2015, in the Skattestrom tunnel in Norway, a tank trailer went on fire. However, no fatalities were also observed in this tunnel. So now coming a little bit more to rail tunnel fires. However, there are not too many rail tunnel fires. So there was one burning train in a station in Koblenz in Germany in 1983. There have been 2 fires in the Eurotunnel between France and Great Britain. The first one was in 1996, the next one was in the 2000 years. And there have been another fire, but in a station and also not in the tunnel, with an ICE train in Germany in 2001. Coming now from rail to metro fires in Hamburg, there was one fire in 1980. 3 persons were injured, but no fatalities. However, a very fatal accident, which you will for sure all know, is the London Metro, the station King's Cross in UK. Was about 31 fatalities in 1987. And a much more severe fire was in the Daegu Metro in South Korea in 2003 with about 196 fatalities. So especially here, 196 fatalities were killed in 2 trains, 147 were injured, 10 of them were firemen. The passengers were unaware of the location and the operation of the fire extinguishers, and they even did not know how to open the doors manually. So, yeah, that is one very important thing which we can learn from this fire. As I already said in the beginning, also terroristic attacks are some further risk for the operation of tunnels. In 2004, there has been some attack in Moscow that resulted in 39 fatalities and approximately 150 injured people. Not a very severe fire has been recorded in the Simplon Tunnel railway, which is a complete railway tunnel. In 2011, there was a fire in one tube. Mainly, it was assumed that the tarpaulin of the train might have had contact with the catenary and started the fire and ignited the load, so that the transported goods were caught by the fire for about, or with about 15 freight cars in this train. So I told you before that the atmosphere is most dangerous for the tunnel users. So here I brought some pictures from the Netherlands. They did some smoke tests inside a tunnel, and that is a quite small fire of about only 5 megawatts. So it's not a very big fire, but you can see how fast the smoke will develop. So this picture was taken about 50 seconds after the fire, this small fire was ignited, and you can see in the back this black smoke coming towards the position of the person who took these photos. So this is about 90 seconds, that means 40 seconds later. This is about 120 seconds after igniting the fire, and this is about 150 seconds. So less than 3 minutes later, after igniting this fire, this very big black smoke, you will not be able to see anything inside the smoke, is coming towards the user. So this is about 3 minutes, and after that you cannot see anything on the photos because the smoke took the position of the camera. So this was just to show to you what is the effect of this smoke, which is very often very lethal to the persons. So to summarize a little bit, what is the result of a fire for the user? So a tunnel fire endangers the user in case of the fire itself. Of course, there's heat, there is fire, you can be burnt, but the smoke, as you have seen in the slides before, is also very poisonous and it can result in the death of people. The temperatures are very high. The toxic substances like carbon monoxide or HCN, etc., they are very dangerous for the passengers inside a tunnel. And because of the low visibility within this smoke, disorientation can occur. And yeah, last but not least, the suffocation due to the reduced oxygen content. However, there's also, so to say, a secondary risk. If some debris will fall down from the tunnel, this also can hurt some people fleeing from the fire. So that was for the users. What is the risk for the firemen? Of course, the fire itself, also the extremely dense smoke, although they can wear breathing apparatus, however, they also influence their work very much. The very high temperatures and the heat radiation is very difficult for the firemen, and also the orientation due to the low visibility. And as I said before, also falling debris and maybe also the spalling of concrete. So what you also can or have seen, also the construction is damaged by a fire, though on the one hand by the direct impact of the fire, but also by burning down of wood and plastic components on the cars, on the train cars or on the heavy goods vehicle. Bursting and spalling of the concrete is the main severe thing. And yeah, also the extreme temperature gradient and the critical deformation of concrete and steel. And in the last stage, then also the disintegration and the collapse of the tunnel. So as a summary, safety is a topic of highest priority and comparable to a chain of proper design. So you also, at the first stage during the design, you have to think about safety precautions for the users, and a suitable construction process, so to make the tunnel safe in itself. But also the accurate operation. So you have to operate the tunnel in the right way, so that yeah, the persons inside the tunnel have a really good chance to flee from the tunnel in case of fire. Nevertheless, even if you take the best precautions at all, tunnel accidents can happen. And especially fires in tunnel can happen. And for that case, accidents require a well-prepared intervention based on a qualified training and exercise of the tunnel staff, but also of the involved firemen and rescue services, etc. So thank you very much for your attention.